Hi everyone, my name is Varun, and today I'll be presenting on the non-invasive assessment of the effect of position and exercise on pulse arrival time to peripheral vascular beds in healthy volunteers. This article was from the journal Frontiers in Physiology with an impact factor of 4.1, which is pretty high. Next, we have the research question. So the research question that was being evaluated were, what are the effects of position, so sitting, standing, and supine, and exercise on pulse arrival time throughout the body, so the earlobe, finger, and toe. And so the purpose of this study was to evaluate the effects of external factors such as position and exercise on pulse arrival time, since that's not well understood, and then also the usability of pulse arrival time as a measurement, as a non-invasive measurement tool. First, to start off, to evaluate the literature that was cited in the article, most articles cited were from journals with an impact factor greater than 3, none less than 2, and many greater than 10. So over there, those are some of the higher impact factor journals that were cited. So taking a deeper look into the actual citations, some of the cited articles were experiments with acceptable sample sizes that did experiments on pulse arrival time. So another one studied location, the effect of disease, etc. And then there's some other articles that were cited that were important in explaining some of the basic science or the physiology or the physics associated with the cardiovascular system that were relevant to the study and understanding. So some other notes were that many of the articles were published more than 10 years prior to the publication date of this article. But to be fair, a lot of those articles were largely explaining the basic science of the cardiovascular system and were not studies. So some of the subjects were 13. The subjects were 13 healthy volunteers without cardiovascular disease, and they were aged 23 to 41. And the inclusion criteria mentioned in the paper were that they were healthy. They had to be healthy adults, aged 21 to 50. And the exclusion criteria were either refusal to participate, known cardiovascular disease, pregnancy because of physiological changes that occur there, and any disability preventing mild physical exertion. And then as far as sample representativeness goes, while it was roughly 50-50 male and female, no information was provided as far as race and ethnicity. But overall, it was probably likely somewhat representative of the population. But it is worth mentioning there was a significant selection bias, as participants were volunteers and recruitment was done via email and word of mouth. There wasn't really much randomization going on. As far as method goes, there was continuous monitoring of cardiac electrical activity done with the 3-lead ECG. Capillary plethysmograph sensors were placed on the ear, finger, and toe bilaterally for the peripheral vascular bed measurements of pulse arrival time. 30-second recordings were then taken of both sensors in the 3 positions and the 3 locations. And then the exercise done was decided to be 30 squats. And then those same 30-second recordings mentioned earlier for pre-exercise were done post-exercise within 3 minutes of completing the exercise. Some more things about the method were that subjects' rights were definitely protected, as subjects were allowed to leave the study if they were unable to complete the exercise. And then finally, Irb approval was obtained from the Johns Hopkins University of Medicine, and there's the Irb number. Data collection was done using an analog to digital converter, so they converted the data into waveforms, digital waveforms that could be easily analyzed following the experiment, and then it was ensured that no time delay was there between the ECG, or discrepancy was there between the ECG and the capillary plethysmograph, which was important because that time difference was critical in evaluating pulse arrival times. As far as methods go, overall, the method's quality was high. The inclusion-exclusion criteria were designed effectively and were done in such a way that the presence of confounding variables would be minimized. So it could have one example could have been cardiovascular disease or pregnancy, and the design of the study itself was excellent as it sought to compare before and after changes in a wide variety of scenarios for each subject, and additionally using the sensors in such a way that time delay was a non-factor was important. So as far as data analysis goes, here are some graph characteristics. Down here we have the ECG signal. So with a standard PQRST wave. Here is the R wave, and then here we have the capillary plethysmograph sensor. So an upward deflection indicates the arrival of a pulse, or the arterial pulse wave, and so the difference in time between the R wave and the arterial pulse wave is the pulse arrival time. And so as far as data analysis goes, we have the statistical. So the first thing that was important was how was the average pulse arrival time calculated for a subject, and it used 10 consecutive heartbeats, which is an appropriately large sample size to ensure accurate pulse arrival time values. Secondly, a parity test was used to compare at-rest pulse arrival times with post-exercise pulse arrival times with the same subject. And that, again, is a correct statistical test for that scenario. And then lastly, to compare pulse arrival times measured at different locations and pulse arrival time ratios between different locations, ANOVA was used, and that's the correct statistical test as we're comparing 3 or more groups of averages. Next, statistical significance. For the most part, pulse arrival times decrease significantly as a result of exercise. So P is less than 0.05 in 6 out of 9 scenarios. So there were 3 positions, and multiply that by 3 locations. So ear, finger, toe. Ratios of pulse arrival time between body parts was statistically insignificant, and that shows that pulse arrival time changes significantly in the body in response to exercise, however, not dependent on location. And so here we have the data analysis, again, showing the significance. So these ones over here at the top, these smaller bars, show how pulse arrival time changes based on the location. So it always arrives at the ear, followed by the finger, followed by the toe. And then lastly, down here, we have the pulse arrival time changes as a result of exercise. So NS stands for not significant. However, these 6 out of 9 scenarios had statistical significance, showing that pulse arrival time largely decreases with exercise. So as far as results and discussion go, a lot of these are mentioned earlier, but pulse arrival time reduces with exercise. Pulse arrival time increases to the toes and decreases to the ears as position gets more vertical, and that can largely be explained by the hydrostatics as you stand. Pulse arrival time ratio, so for example, pulse arrival time of the toe divided by the 1 of the finger is generally only dependent on exercise status. And then lastly, ear, finger, and toe is the order at which the pulse wave always arrives in the body. Some limitations were that results are not generalizable beyond the young and healthy population. The sampling method was not randomized and a volunteer-based study, and it did not normalize for blood pressure and heart rate. So even though these patients were normotensive, it is important to still normalize by BP and heart rate because those can affect pulse arrival time significantly. So the author's interpretation of these results were that it was consistent with other recently published literature in the field, and that pulse arrival time results roughly matching the hypothesized results show that pulse arrival time in combination with pulse arrival time ratio are effective measures of the vascular system and are comparable in usability and effectiveness to other common non-invasive measures of the vascular system, pulse wave velocity and pulse transit time. And then lastly, as shown with the 2 figures that I put on the slideshow, the presentation of results is effective and appropriately shows statistical significance in relatively easy to read charts. The last thing I want to cover is the significance. So as far as implication goes, pulse arrival time is particularly responsible to external factors such as exercise and maybe even other things, and is an effective non-invasive tool in comparison to other established vascular measurement tools such as pulse transit time and pulse wave velocity. So this contributed important information as far as the effective position on pulse arrival time, so like sitting, standing, supine, and then the effect of exercise on pulse arrival time. The study has a procedure that is easy to replicate. The methods and data collection procedure are all presented well, though subject acquisition could have been better. Some additional questions were that how does pulse arrival time change with age? How does it change with different types of cardiovascular disease, such as heart failure, different types of arrhythmias, and even hypertension? Thank you for listening.